I got the window seat. I had the chance to look out the window, and the view was super pretty. A lot of lakes, water, patches of green, blue. I was like, oh, can we preserve this kind of view for the future?
The aviation and aerospace industry, for decades, it has followed this model of performance first, cost second. Somewhere down the list, we'll think about the planet. And that order has to change.
Why would any operator / manufacturer actually go towards that carbon neutral approach unless and until they see justification happen?
The biggest issue with aviation fuel is energy density. ATF, which is aviation turbine fuel, still contains highest amount of energy density. I want you to think of it, you cannot just put in a Tesla battery into an airplane, especially in civil aviation where weight is everything.
The biggest issue is energy density. We're not able to produce enough energy per volume, and that is why we haven't switched to it yet. I don't expect any airline manufacturer or producer to do anything about it. I think they care more about their profits than they do about the environment.
It's kind of a hot take there. I don't
I'm
know
here for the hot takes.
why wouldn't the companies also not look into it if there's a financial aspect.
The electric side, you can think about hydrogen fuel cells. You can use this for short flights, like prop flights. Right? Another method comes from rocket propulsion, where you just straight up use hydrogen, burn it in air.
And you want to go back and do your thesis on it, don't you? Just throw a ramjet on them and then just fly.
Now, you could do this, right? Who knows? Maybe tomorrow some kid is gonna come up with a great idea, and he'll be like, I heard the podcast, they gave me an idea, and I made it.
For the last 40 years or maybe more, we have not changed the design of our aircraft. With many companies like this, Auto Aerospace, which is trying their best to have cool designs, aerodynamically much more efficient designs to have lesser fuel burns.
Previously, just launching one satellite used to enable massive amounts of wastage, and the capacity to reuse a launcher itself saves so much. If two satellites hit each other, there is going to be a bunch of space debris that comes out of it. That debris is going to start hitting other objects, and it is going to exponentially increase the amount of debris in space. Now, with the increase in the SpaceX satellites, the Kessler syndrome is no longer a theoretical concept. This is something that could be an eventuality, and most of it is going to fall on us. When it comes to space travel, I think it's about ethics, because there has to be an ethical call on planetary protection and long-term sustainability. Outer space belongs to all of us. It belongs to all of us as humankind. If there is no sustainability as part of the business, we are very slowly ensuring that there is going to be no future.
Hey everyone, welcome to another episode of Ground Control to Major Nerds. We have a full house today. So we have Ashwini and Parvesh.
By popular demand.
Let's go around and see what everybody's up to. So Ashwini, how's it going? How have you been?
Going really well. Celebrating Diwali. Happy Diwali to everyone.
Happy Diwali, everyone.
Yeah, that's
What did you do for Diwali?
Diwali time is just all about food and celebration, spreading positivity and love with friends and family, and at the workplace as well. So just having a really nice, positive time.
Great. And you, Parvesh, how has it been for you so far?
Pretty good. I had a bunch of traveling to do. I flew to Hyderabad a couple of weeks back, and then I flew back to Chennai yesterday.
Great. It's been good weekend for us over here, and been doing some good research to bring us to today's episode, which is sustainability in aviation. Specifically, I think there's no specifics over here, so we're gonna try to cover every aspects of sustainability in aviation. So, Parvesh, I would start with you first. So, what do you think when you hear the term sustainability from your aspect? Where do you start looking at it from?
Let me bring it back to my flight, okay?
Okay.
The flight from Bangalore to Chennai is, for the first time in a really long time, I got the window seat this time. So I had the chance to look out the window, and the view was super pretty. I took like a bunch of photos. You'll see like a bunch of green, a lot of lakes, water, like patches of green, patches of blue, and small rural areas everywhere. So it's very pretty. So at least in my head, I was like, oh, this view is very pretty. Can we preserve this kind of view for the future? And at least from an aerospace perspective, I feel like thinking about like combustion, propulsion, it would come down to fuels for me. To find fuels that can do very little damage in terms of emissions and nitrogen emissions, all that kind of thing, like reduction of all of those. So that would be my top pick. What about you guys?
I guess, like, yeah, I mean, that's the first thing I think when people hear sustainability, right? In aviation, like, that's the first thing they try to look for. So I think that's one of the biggest ones too. So, like, I'm not like surprised you being the propulsion guy, like, you being the guy who actually is curious about more about propulsion and, engines and stuff. So, and also working in the MRO side of things. So you might be much more familiar with these kind of topics. So let's like kind of like dive into it. I mean, Ashwini, if you have something to add on to that, or maybe like if you want to talk about something to do with sustainability in fuels, or in terms of the propulsion side of things, or combustion
I
engine
mean,
side.
before we get into sustainability specifically for aviation and aerospace, I think a good idea would be to understand what is sustainability and why
Okay,
exactly
yeah,
do we need it. So,
cool.
just a few notes that I wrote down. Sustainability, as defined
Mhm.
in the dictionary, would be the practice of meeting the needs of the present without compromising the ability of future generations to meet their own needs. And what I understood from it is essentially it involves using resources responsibly to ensure long-term environmental, social, and economic well-being, not only for the present generation but also for future generations. And this is something that is very important as of now, because I would say that we are probably the first generation that is experiencing the long-term effects of uh, non-sustainable practices in the industry that started through the industrial age for the past, say, 40, 50 years. And we can actually see actual ecosystems completely vanish, disappear, uh, large hordes of species, whether those are plants or animals, just completely get extinct. And it is affecting not only the environment, but it is also affecting us. We are seeing rises of epidemics, pandemics, diseases. Uh, this is
Climate
all
change.
climate change. And so this is all the effects of a non-sustainable practice where we are not taking care of the earth that we are surviving on. And I think it is extremely important. It is one of the most important practices that we have to bring not only to aviation and aerospace, but to our daily lives, to each and every part of our life, where we have to have a longer understanding of our actions. We cannot just live in the present, but we also have to think about the future. We have to be extremely mindful and considerate for the future generations. So that is essentially what sustainability is. And bringing it into aviation and aerospace, uh, it is one of the niche industries. If you look at purely statistics, and I'll just bring it to you, uh, like Parvesh mentioned, fuel. We would say global carbon dioxide emissions from aviation aerospace still account to only 2 or 3% of the total large scale emissions. But it is one of the hardest sectors to decarbonize. We are looking at decarbonization and carbon offsets in every industry right now. But for aviation and aerospace, decarbonization is something that is still a long way.
Well,
So, yeah, so basically, I'm just setting it up that we have to discuss and we have
I
to
would
be
like to,
very aware.
yeah, I would like to connect the dots on this exact moment that you're right, like the scenario that you're talking about. But first, I would like to know, like, okay, what kind of fuels are there? What kind of,
Exactly.
avenues that have been explored that, like, even though they have been explored, why are we not able to decarbonize the industry? So let's go with that narrative first. So, like, Parvesh, what do you think are the major, like, researches slash implementations that have been tried in the aviation industry to bring sustainability in terms of maybe fuel or engine side, or which is the biggest carbon emitter, basically, which is the engines?
Yeah, that's what I was actually about to say, because I don't have like what we're currently doing, because we're not doing much right now.
Understood.
But
But
what I have are
what
like
have been tried?
possible,
Yeah.
yeah, possible either what have been tried or avenues for research where people can take it forward. So there's a few uh, aviation fuel types. So one of the thing is biofuels, hydrogen fuel cells, and then there's a few synthetic alternatives that can be used. There's a reaction. I guess it's a carbon capture reaction, which is called the Fischer-Tropsch reaction. Basically, it captures carbon monoxide, carbon dioxide from the air and pulls it in and mixes it with water to create complex hydrocarbon chains and hydrogen and water.
As the
Oh, wait.
byproduct of it.
Yeah. So carbon monoxide and carbon dioxide along with hydrogen to produce complex carbon chains and water as a
Okay.
byproduct.
So
And then
what are
you
the
reburn the carbon chains and you'll release carbon dioxide and water again.
Got it. So I guess the bigger thing is like I'm definitely on the avionics and the in like on the more on the system side of aviation, right? So but like just to pick your brain on this, like what do you think would be the intent over like doing this kind of like trials slash experimentation of biofuels?
So this reaction exists, right? It exists.
Sure. Yeah.
But the biggest problem with this reaction is it requires a lot of energy to capture carbon dioxide, carbon monoxide from the air because you need to isolate it, right? And you're mixing it with hydrogen. So when you're mixing it with hydrogen, nitrogen's there in the air too. So you're pushing out nitrogen emissions as well.
Mm-hmm.
And at the same time, it requires a lot of energy. So this is one of the drawbacks why we're not able to use it sustainably, continuously.
Yes, but like, what is the intent behind? I think the
It'll be
intent is
carbon
to
neutral, right? So you're
carbon
pulling
neutral.
carbon
Okay.
dioxide from the air and then you're putting it back.
Okay. Cool.
So there's another one where it's called hydroprocessed esters and fatty acids. Basically, this is like hydrogenation of fatty acids. You remove the oxygen, and that is the oxygen component in the fuels. And then you will create something that is basically like diesel or jet fuel from like conventional oils. It's like your supercharging oils, basically. Like you
Got
can
it.
use even like used vegetable oil, something like that, right? From once you start using the vegetable oil, it'll form like different kinds of oils. It'll no longer be homogeneous.
But
So
here's
at
my
that point,
question.
you convert it. Mm.
Got it. But here's my question. So there's always this debate, which I've always heard with at least the Part 33 folk, right? Like, so they would always want to go for the higher octane fuel or like the high efficiency fuel, so that even though it is much more susceptible to emitting carbon, but actually because of its higher performance and higher, gradient to give output, in a way, you're actually being more efficient in burning those fuels. Yes, it's expensive to basically refine them, and also slash they're expensive in operations and stuff, but in general you're using like 1 kilo, like 1 gallon of that to produce x amount of efficiency, whereas like biofuels or vegetable oil reuse, vegetable oil might require like 5 gallons of those instead of 1 gallon of that high octane
No. So
gas.
if you think of it like you can't actually think of it like that. From what
Okay.
I remember, right, octane is basically eight carbon long carbon chain, hydrocarbon
Yes.
chain. But even vegetable oils are long chains. They're not small. But the problem is they have other things in it which cause the inefficiency. So when you supercharge it, basically hydrogenate it and remove all the oxygen from it, you're making it a large hydrocarbon chain, and it's still viable to use as a jet fuel. So it's
Got
going
it.
to give you the same efficiency. In fact,
If I
I think
can, sorry, go ahead. Sorry,
they,
go ahead.
I think you're going to talk about it. Basically, they mix biofuels with regular jet fuel to save on some jet fuel usage, basically. Is that what you were going to talk about?
I was going to get to it, but from what I
Okay.
understood, what Srikant was talking about, and this sort of ties up with what you're talking about as well. Currently, the biggest issue with aviation fuel is energy density. That is the term that is completely the deciding factor. Where
Mm.
ATF, which is aviation turbine fuel, that still contains highest amount of energy density. What is energy density? It is basically a ratio of how much energy you're getting for how much weight of fuel you're carrying. Hence,
Exactly.
it
Yeah.
has the unit of kilowatt per kg. I want you to think of it in layman terms that you cannot just put in a Tesla battery into an airplane and expect it to give you the same amount of kilowatt for the same amount of weight in terms of aviation fuel. So you will get more power out of lesser weight for something like aviation fuel as compared to something more like a biofuel or anything that is new age. And that is what the biggest factor is, especially in civil aviation, where weight is everything. Any
Yeah.
excess baggage, I'm sure all of you traveling know that every kilo extra is
Hmm.
charged. So,
Yeah.
weight is very important. And that is why energy density is something that is still the biggest deciding factor. And what you were talking about in terms of aviation fuel mixing, basically from an India point of view, this is what I'm aware of in India. The Honorable Civil Aviation Minister in India, which is Mr. Ram Mohan Naidu, he's I recently attended an event where he was presiding over a conference where they came up with this entire sort of Sustainable Aviation Fuel, or SAF. It was a feasibility report on it, and they basically tried to come up with a practical and immediate solution to decarbonize the aviation sector, because they're saying it's high time again to become sustainable, and they want to become sustainable, all of that talk. And basically what it was reported as is that the Ministry of Civil Aviation, along with the partnership of the International Civil Aviation Organization, which is the ICAO, they want to get support from the European Union, and they want to officially release a pathway for the use of sustainable aviation fuel. And what that means is essentially you will have a pathway which is 1% sustainable aviation fuel by 2027, 2% by 2028, and 5% by 2030. That is what is practical right now, because otherwise they would be messing up with the energy density. And this is at the backup of experimentation that was done starting 2020, where they had gone up to 20% blends of biofuel and tried it on civil aviation aircrafts with no passengers on it. And they had said that this is something that is definitely sustainable, but the blending has to change. And with passengers, with luggage, the amount of use of this fuel will increase. So that is why this is the blending targets that India aims to meet. And yeah, that's basically
I
as
guess.
per these global CORSIA mandates. Yeah, go ahead.
I guess, like, just to summarize, right? Like, coming from a big picture perspective, at least for me, I think the bigger question is just, it comes back to that, right? Why would any operator slash any uh, manufacturer would like actually like go towards that carbon neutral approach unless and until they see this kind of justification happen, where if I'm burning 1 gallon of a fuel, yes, I get it, I'm actually also emitting enough carbon, emissions that I'm doing for it. But for my operations and for my efficiency purposes, I'm actually justifying the efficiency of a high octane slash a high energy density fuel that I'm burning. So for for sustainability purposes, yes, maybe, like, using an alternative fuel might, uh, reduce the emissions per gallon of what you're trying to burn, but you may be not efficient enough, and maybe you may have to carry more fuel than required for a trip, for example. So I guess that's where this is a debate I've always heard in the industry for this, and hence, like, there's a very slow ticker that's going around to get towards that direction, and no, I'm not seeing an accelerated ticker. At least you guys can correct me if I'm wrong. So yeah, that's my only knowledge on that.
Yeah,
So
like
I'll let
that's
you
the
say more.
biggest issue, right? Like the
Hmm.
biggest issue is energy density. We're not able to produce enough energy per mass or per volume, whichever. And that is why we haven't switched to it yet.
What do you think about electrification of an aircraft?
I was going to
What's
get to
your
that
stance on that?
next.
Okay. So now that
Before
I've
we
now that
do,
I've summed up.
before we do, could we
Okay.
just very quickly talk about Just one final bit on this
Yeah.
Yeah, go ahead.
entire biofuel section. There is a certification that has come out. It's called ISCC, which is the International Sustainability and Carbon Certification. This is done by an agency called COTECNA, COTECNE, and
Okay.
this is a European Union based recognized partner. And this certification helps in identifying what the pathway should be, what the correct timelines are, and what are the right certification percentages, where you are not jeopardizing civil aviation travel, but also able to sustainably grow and sustainably make pathways where this is the future. So it is going to be an interesting thing, and there is definitely a lot of certification work that has come recently into the picture, and it is the way forward. So that is my bit in terms of certification. And now we can definitely talk about electric.
So
All
one more
right.
thing, I feel like the thing is, my view on this is, I don't expect any airline manufacturer or producer to do anything about it, because I think they care more about their profits than they do about the environment or whatever. So I'm looking at this from a perspective of I'm hoping future engineers, like who are studying, doing PhD, things like that, they look into it more rather than companies. I don't expect companies to look into it, but I do hope that students will.
It's kind of a hot take there, but like I
I'm
don't
here
know.
for the hot takes.
No, I get it, but like I don't know why wouldn't the companies also not look into it
They
if there is a
probably
financial
would.
aspect. Yeah, but I
Yeah,
mean,
but it's going to
but I
cost
think
more than their current, unless there's some push from like the government or regulations come into force. They're not going to have the pressure to do it, right? They might be looking at it somewhere in some on the side somewhere.
I feel like
Ashwini has to say something.
yeah, I know Ashwini wants to say something. I just want to I want to quickly say something about this. So, like, I feel like if it is scientifically possible but financially not possible, right? um, there is still a thing that could be debated about, like, okay, it's not sustainable, right? Ultimately, you're trying to find sustainability, like how Ashwini gave the definition in the beginning. Sustainability is something that you try to improve certain thing without jeopardizing the future, right? So if these kind of, like, if scientifically it's possible but financially it's not, it's still not sustainable. So that's where I think that's my 2 cents on it. But yeah.
My view on this is it's not as black and white as Parvesh is looking at it. It's not tree
I
huggers
agree.
versus
No,
capitalistic
I agree with
bigots.
you.
Yeah, that's true.
it is,
This
it
is
is,
one topic which
but
is not. I get it. Yeah.
but at the same time, you are right. The push for a different sort of fuel will not be on the basis of the fact that it is greener and it is going to help the future generations. Of course, revenue and profit is the bottom line for any private entity. My point to you in this is, currently, civil aviation depends on only one kind of fuel, which is ATF. When you have only one thing which you are completely dependent on, that becomes a commodity which is monopolized. And currently, we are seeing that ATF, which is a highly blended, not blended, but highly, what's the right word? Uh, Refined
Refined, yeah.
version of crude. Uh, if crude is something that is falling off, the reserves of it are coming to an end. ATF, by definition, is going to become more and more expensive. So there is going to be a day where any alternate source is going to be just another option. If you're solely dependent on ATF, its value can just change and you are still dependent on it. So as a private entity, you have to find newer sources. You have to find another sort of source where you can then pivot to if ATF is just way too expensive for you. Otherwise, that monopoly is just going to kill you as an industry anyway. So there is a need purely from a money point of view as well. That is why big companies like Boeing, like Airbus, they're looking at integration. And engine manufacturers like Pratt and Whitney have their in-house programs looking into engine manufacture using new sort of fuels. And like you mentioned, electric and hydrogen are one of the two important sort of sources there, because there is a lot of work happening in this field. Uh, Before you get to the positives, I'm just going to throw in a negative. Currently, the infrastructure at major airports where flights coming in after landing and getting refueled, the infrastructure is just not ready for any alternate sort of fuel. So that is something that has to be majorly invested into. That is only when this industry can pivot to a different sort of fuel. Currently, everything is made for ATF, and we are completely monopolizing our infrastructure and our usage of ATF. So that is one thing we have to immediately fix. Now you can talk about what are the positives, because that is something I don't have much knowledge on.
I guess, I mean, rather than speaking about the positives, I mean, unless Parvesh has something to say about it,
Yeah, no, not about
Mhm.
positives, but just I wanted to finish up electric and
Yeah, sure. Yeah,
hydrogen
go for it.
fuel. So there's two methods. One, um, for the electric side, you can think about hydrogen fuel cells, which is basically hydrogen and oxygen react within a fuel cell. They generate electricity, which powers electric motors. You can use this for short flights, like prop flights, right? So that is one method. Another method comes from rocket propulsion, where you just straight up use hydrogen, burn it
Yeah.
in air. And
You want to go back and do your thesis on it, don't you? Just throw a ramjet on them and then just fly. Uh-huh.
now
Yeah.
you could do this, right?
Of course you could.
It would work, but you would have a couple of issues. One is because you're still in like the regular atmosphere, you'd be like throwing out uh, nitrogen compounds, which will end up reacting with the oxygen and hydrogen at high temperatures. And then you'd also need liquid hydrogen, right? So you'd need like cryo tanks where you store all the liquid hydrogen in, I don't know where.
Great. So you went into the experimental mode of it. I was talking about sustainability over here.
Dude,
So
it's an idea. It's who knows?
I know
Maybe
it's an idea,
tomorrow
but I'm just saying
some kid is gonna come up with a great idea, and he'll be like,
to
"I
make
heard
the
our
tanks lighter.
podcast. No, I heard the podcast. They gave me an idea, and I made it. See?
Maybe,
I
yes.
mean, yeah, it's not just ideas, but there are genuine concepts out there which we can refer to for hydrogen fuel cells or use of hydrogen combustion. There is the Airbus Zero E concept. There is also Rolls-Royce Spirit of Innovation. And there are some small-scale aircrafts that I had written down while researching this topic. There is the Pipistrel, there's Aviation Alice, and there is the work of Heart Aerospace. These are all companies or concepts that are utilizing the chemistry or the use of hydrogen combustion or hydrogen fuel cells. Whether that is something that can be commercialized into large scale operation is still something that we have to see. But with
Still
all of
expensive.
this, it basically hydrogen is giving us hope, and it is clean when it burns, and there is high energy density. So we are definitely uh, on the right path. But the question that we have to ask with hydrogen is not that uh, can we fly using hydrogen? It's basically can we build an industry around it? And that is basically what we have to answer.
Got it. Okay. So
And finally, there's also there's also a few synthetics like synthetic methane, algae-based oils, and ammonia. They're all like experimental. They have like a bunch of challenges. They're like toxic. They might not burn properly. If something like synthetic methane leaks, it's a greenhouse gas in itself. So yeah. So that's all I had.
cool.
Oh,
So yeah,
do
I
you?
mean, yeah. So I mean, the reason why I started off with the fuel topic and also like looking into the fuel is because I think that's the most obvious thing when anybody who is maybe having some intuition towards what aviation is, or what commercial aerospace is, like just by flying around, like having taken few flights, I think one of the biggest thing that looks apart is the engine and the fuel burn that they always see, right? But in my opinion, I think the biggest cost saving and efficiency that you can do, especially on fuel burn, is your internal weights of the aircraft and also the design of the aircraft in itself. So, which is kind of fully under our control. And I think it's fair to say, like, for the last 40 years or so, maybe more, we have not changed the design of our aircraft, with just because you don't want to certify a new design, basically. So that's the other side of, sustainability, which I wanted to point towards as well, especially like the aerodynamic side of the aircraft. There are many companies which are coming up and doing these things, like there's Auto Aerospace, which is trying their best to have cool designs, aerodynamically much more efficient designs, to have lesser fuel burns and show more like distance covered for the amount of fuel they carry, basically. And if you look at, like, coming from a business jet, like development perspective, I think one of the biggest selling points for a business jet is how far can that jet travel with the amount of fuel, and how fast can it travel, right? So then it comes down to the design itself of the jet. So I think that needs to transition towards commercial aerospace as well, sooner than later, because I think while by the way, Airbus A320 Neo program has actually tried, and also the A350 has tried. Even 787 and the 737s have tried. But I think there's still more room, I feel like, in terms of those, innovations that could be done. So that's my 2 cents on that. But yeah.
I haven't looked it up, but I'm wondering, would it be more efficient to have multiple shorter flights or like one really big flight?
It's always been a cost driver when you have to have an operations with a stop, regardless, because I think the biggest fuel consumption happens during the takeoff of an aircraft, because that's obvious. I mean, you're burning the
No,
most
but
amount
let's
of
say,
fuel when you're taking off.
because in if you're using a prop, right,
Doesn't matter.
you
You're
can
still you're
you
still
can
trying to
switch
you
to
still
electric, right?
again, now that's something, if it is practically viable and also shows like the sustainment side of things of the design, then yes, absolutely. But it depends upon the if you're talking about a 737 or or an A320, which is a like kind of like a smaller aircraft, but it's still big. But yeah, if you think about operational side of things, if you have more number of stops, it makes it much more worse for operations than better. The electrification might help,
Other
but
stuff will
how would
get
you
more
certify that?
expensive.
Yeah. Yeah. Every takeoff, you burn, like, I mean, Ashwini can correct me, I think 30% of your fuel is burnt during takeoff itself, or even
I'm
more.
not I'm not aware of the percentages, but you're right.
I
Maximum
don't either.
fuel
Yeah.
does happen during takeoff. That is why it's called TOGA, takeoff go around power, and it consumes maximum fuel. But Parvesh brings an interesting point about till now, essentially the aviation and aerospace industry for decades it has followed this model of performance first, cost second. Somewhere down the list, we'll think about the planet, and that order has to
Mm.
change. And I think the suggestion of using smaller aircrafts with more stops is a valid input, but it is going to massively throw pressure onto present infrastructure for operation. The number of ATCs will increase, the traffic in the air will increase. We have spent the last few weeks discussing how an increase in traffic is already pushing uh, too much stress on
Safety.
a slowly bursting bubble of safe aviation. So,
Yeah.
smaller aircrafts, more aircrafts in the sky, smaller routes, it is definitely going to be slightly more sustainable, but at what cost? So this is why you have to come up with an infrastructure which is supportive of all of this, and then you have to start making these changes. Having said that, uh, the point you mentioned about manufacturing and designing for sustainability. I feel like this is a very interesting topic, and this is something engineer to engineer we should definitely have a conversation about. And there is an entire life cycle of emissions that we have to take care of, whether that is materials, whether that is supply chain, whether that is maintenance or end of life. All of these are things that can be made more sustainable. And one example, especially during manufacturing, is the use of additive manufacturing rather than subtractive manufacturing, wherein with traditional manufacturing process, there was already a lot of material that was wasted. Rather than that, using additive manufacturing has drastically reduced the amount of waste. And that is just one part. So, such interesting concepts, they are all something that come out of a lab. They're all something that come out of an interesting thesis that happens at a university. But it has to be something, and this is my request to anyone watching. If you are in the engineering field and you come up with an interesting idea, try to make it achievable in industry. It has to be scalable. It has to work economically. It cannot just be cool. It has to work economically. And that is the design philosophy. If that is something you can follow, if that is something I can follow, I do see things changing there.
Yeah, absolutely. Okay, so let's switch gears. So that's the design side of things and the performance side of things of sustainability. How about like sustainability in the business side of things and the operation side of things? Uh, Anybody wants to start off with that?
Start. We'll jump in.
So for me, at least, like I think from being from a system side of things, I guess I think I think this still falls under design. It's not purely business, but I think avionics development becoming much more like robust and much more like the designs being much more like smarter in terms of like how many boxes used to be first before used to maybe like do like a simple data gathering sort of a like activity now has become like a whole like a network which would then reduce like maybe around 70 kilos in an aircraft, for example, which is the system that I worked on, at least the DCN, the data concentration network, something like that, like what Airbus and Boeing now heavily use in all their future designs. Things like that have actually innovated and made sure that from a business standpoint, yes, it is better for operations because now you have less number of boxes to maintain and less number of wires to deal with. And also from a weight perspective, it has now reduced the weight of the aircraft too. So those kind of innovative designs have actually brought in sustainability. But yes, it has increased the complexity of the aircraft to become more software based. So there is some like trade off over there for that reasons. But other than that, I think those are the also the aspects where from a business side of like things, there are the technology has been advancing towards being much more smarter of the of the aircraft being much more smarter to do things much more efficiently, but also it has improved and helped the operational side of things as well to reduce costs and reduce overhead for those things. So that's one aspect of it.
Last week, you guys were talking about HUDs, right? HUDs.
Yeah.
I wonder if you can integrate some HUD to say, like, hey, like this part is inefficient. Can you like switch on this module or something like that?
Wow. So that's the problem, right? So you cannot bring in like any kind of non-flight ops into the cockpit, which will be like, right there in front of pilot's face. Like what would the pilot do with such an information? Kind of like I'm just trying
Oh,
to.
let's say like there's a good time to switch on autopilot.
Yes. So that's the flight management
Just,
system
I
already
don't
does that.
know.
There's a very popular pilot joke that goes, the best time to switch autopilot is as soon as you can.
Exactly. We don't want pilots to do anything, as I mentioned in the previous episode. So yeah.
This cannot become an anti-pilot sort of association with like hate against pilots.
No, it's not hate against
Your
pilots.
brother is a pilot.
I know,
It's
right?
not, it's not hate against pilots. That's the thing. Like, I think it's about reducing the human factor errors that are possible to happen. Basically, I joke a lot about pilots being whatever, but it's more about like having much more reliable systems. And by the way, it ties into sustainability. If you have to stress a human being in the loop a lot more than required, it is not sustainable for operations sake as well, because any mistakes that are caused due to an input error just makes it inefficient of a system, right? So to reduce inefficiencies, you want to have more automation, you need to have more reliable, robust automation. So autopilots is one of them. And also, like, I think uh the target, at least for some manufacturers, I can't remember, at least like the way the systems are going towards is having less than 3 or 4 activities for a pilot in a cockpit. Is that what is the world that we are trying to go towards? And it's not because we don't want to rely on pilots. It's more about creating that efficiency, that repetitive process, a processed efficiency that comes in, wherein there's no surprises on how each and every event in the flight happens. So if we can predict that and automate that, then we have much more sustainable operations in the field.
Since we were talking about sustainability practices in business, in the business side of aviation and aerospace, I'm going to go a little doomsday and just say this, that the best sort of practice for any business in aviation and aerospace is to ensure that there is future business. And if there is no sustainability when it comes to uh, everything else as part of the business, we are very slowly ensuring that there is going to be no future. So it might sound a little doomsday, but to ensure that we have business tomorrow, we need to ensure that there is a tomorrow. And one of the strategies is Corsia, which is a carbon offsetting and reduction scheme for international aviation. This is something that is a legitimate target. And I know that Airbus and I think basically Airbus has come up with a roadmap along with IATA where they are saying by 2050 they want to drastically reduce their carbon emissions. And apart from this, I feel like the push has to come in from regulatory authorities and from governments, where there is a carbon pricing, there is an emissions trading, and you have to ensure that airlines are adapting so that I'm not saying they're forced into it, but there is a pathway and there is a regulation which they have to then follow to ensure that there is a tomorrow for all of us. And this is where I feel like the role of government bodies and the role of regulatory bodies is slightly higher than the private industry itself, because like Parvesh previously pointed out, private industry is going to look out for profits, but regulatory bodies are the ones who are supposed to set up the rules and regulations here. And it is not just about better engines or having better processes, it is about better economics. And as a private company, of course, if it is not profitable, we will not fly. But we also have to ensure there is profit along with sustainability. I feel like that is the angle we have to consider.
True. What else
Space.
are we thinking about? Space. What about
There's
space?
not that much space, bro.
I feel like there is a very interesting conversation we should have talking about sustainability in space, that is outer space. And it is completely dependent on this very interesting syndrome I read about a few weeks ago. It is called the Kessler syndrome. And Kessler syndrome simply says that if there is some sort of incident in the atmosphere around us where there are satellites orbiting and there is a lot of space debris, if there is some sort
Oh,
of
everything's gonna follow.
right, basically if there is an interaction where two satellites hit each other, there is going to be a bunch of space debris that comes out of it. That debris is going to start hitting other objects, and it is going to exponentially increase the amount of debris in space. And this is something which I felt was a theoretical concept years ago, but now with the increase in the uh, SpaceX satellites, they're already affecting photography, outer space photography. You can see that traces come into all of these parts. But with the drastic increase in satellites, the Kessler syndrome is no longer a theoretical concept. This is something that could be an eventuality. So if this is something that happens, there is going to be a lot of debris and most of it is going to fall on us. So
So
that is not
the,
sustainable.
that is definitely not sustainable. But I think the same concept goes on the aircraft as well. Like when you're designing a system or when you're trying to do any kind of like manufacturing operations or something like that. I mean, back in the day, it used to be just handwritten processes going around, cascading. Like, if the person A has not done the job, the person B will not start his job, sort of a thing. So it used to be always end to end working, models that used to be there. I think the space operations are also kind of like that, where if they find like a separation spot in the orbit, in like Leo orbits or anything like that, they will just insert like a satellite without understanding. So things like that are happening, and I guess like this is something which is coming back to haunt us now, where now that we didn't have any processes on how the satellites were put in, or maybe there is. Maybe I'm not educated enough to know that. Maybe somebody can correct me if there is or there is not. But it's the same policy that is now repeating again in the space as well. So yeah.
More than the satellite falling on us, most likely it'll burn up before it hits us, at least to
depends
some
upon
extent.
depends upon the size of the
I'd
satellite,
be,
right?
yeah, but still, like, it'll first break into bits before once the debris hits. But I'd be more worried about the infrastructure itself because we're largely dependent on the satellites itself. And if they start breaking, like, most of our current infrastructure will fall. So we need a way
Depends.
to,
Depends in which orbit. So the geo orbit is not
whichever
as.
orbit, debris will go everywhere.
No, but the debris will not go towards the geo orbit. Geo orbit is too far away from the Leo orbit or the Meo orbits, right? So, I mean, the most amount
Yeah,
of
but like,
concentration of satellites are in the Leo and the Meo orbit. So, maybe your YouTube videos will not work for a week or so. But other than that, the major infrastructures will be online. So,
No, but it's an
again,
interesting
but
conversation to have.
it's an interesting concept. Yeah, it is still a thing.
I,
It's still a problem. So yeah.
I think we should be very positive, especially talking about reusability of launchers. That is such a big step towards sustainability. Previously, just launching one satellite used to enable uh, massive amounts of wastage, and the capacity to reuse a launcher itself saves so much. And I feel that this should be expanded. We can expand this to other sectors as well, other operations as well. I feel like another part is the use of propellants. I feel like there is some research going on to use cleaner propellants, to use greener propulsion. And I feel like the chemistry behind is a little more complex. And that is something that is way beyond me. But I know that there is work happening on green propellants and on cleaner propellants. So that is something that we should encourage, and there should be a market for this. There should be research on this. And finally, when it comes to space travel, I think it's about ethics, because there has to be an ethical call on planetary protection and long-term sustainability, where we cannot just blindly throw stuff into space and start altering what our solar system is. Because there is regulation, although it is not something that is completely hard and fast applied, but there is regulation, because outer space belongs to all of us. It does not belong to any private entity or any country. It belongs to all of us as humankind. So there has to be an ethical reason behind sustainability of outer space. We cannot just limit it to Earth. It has to be to the larger sense of the universe. So I feel like that is also something we should consider.
To be
I
honest with
guess
you, the
another
whole
point here, sorry, I guess another point here would be like to improve sustainability for satellites at least. We can think about a way to more easily decommission and recommission older satellites, do any form of servicing for them, things like that, right? That might be another way for sustainability.
So I was going to say this should be a completely separate topic of discussion, because there is a whole organization that
Next
actually
episode.
is, yeah, the next episode maybe, because there is a whole committee in the European Space Agency that is tirelessly working on decommissioning satellites which are just lingering around and in the orbit, and like they have stopped working, or their utility has been, like, past its expiry, sort of a thing. But no company is claiming them, or nobody is claiming them as responsibility to, like, get them safely back to Earth or get them out of the orbit. So there is a lot of space debris like that lying around, which the European Space Agency, along with like other space agencies in the world, the last time I read, is trying to work towards the plan to, clear off the space debris, basically. So again, as I said, like, that's one part of sustainability that we should be talking about, but I think there should be a separate episode where we should be discussing that in depth on how it does happen. So yeah.
It's an idea for venture capitalists. Think about
It
it.
is an
New company.
idea, sure, but it's already getting done. So I guess they would be behind the
So
curve.
they can start a company like that.
If there is one more point that I guess if you guys have any ideas, the hot topic of discussion these days, at least for the last 2 years, has been the use of artificial intelligence, the use of IoT, and the use of digital twins to improve and to make things more profitable. Can such systems be used for sustainability?
Yeah. So just to give you an anecdote into this, so there are systems like the aircraft health and aircraft health and trend monitoring, which does the same thing. They use the IoT model to actually like have uh, like a predictive maintenance sort of a like approach towards using the data, which actually, like, you have X amount of aircrafts in your fleet. That means you have X times 2 amount of engines that are flying around, depending upon what kind of operations those aircrafts have been doing, and when were they last maintained, and what kind of weather patterns they have flown through, and also their live, telemetry of their sensors in the engines itself, the FADEC system giving out faults live. They can predict on, like, okay, what is the next possibility of failure that could occur, or before the failure could occur, could you do a line replacement of that unit, and then, like, just as soon as it lands, have a, quick transaction of that unit being swapped around, just to avoid the future legs being, jeopardized. And that brings efficiency and that brings sustainability to the operations. So those kind of methods are kind of existent, but they're not widely being used, I'll say that. So things like that need to come in now, especially with the satcom industry being so strong, with so many satellites up there in the sky. I think there is always a way to improve those data points to be live, broadcasted to the operators and to the aircraft manufacturers or to the mechanics, so that they can have better, turnaround time whenever there is some failure in the fleet. We see so many airlines having delays. I think that those delays could be quickly, like, uh, eradicated, other than the human delays, which is basically shortage of pilots or ATC due to government shutdown that's happening right now. But other than that, anything which is not man-made, and anything which is systemic, I think, yeah, the techniques that you pointed out towards, there is a huge influence of AI in these aspects of data points, and to process these data points. So yeah, there's a lot of work getting done there, and also improving the processes itself of how you operate in that, environment. It's hugely impacted the efficiency of the whole operation. So yeah, but there's still a lot to do.
I love this discussion because you have basically uh, you've just basically covered everything that I wanted to point towards, and in the same order. I had written down these things to discuss, and you have perfectly summarized this because uh, it is the use of sensors and devices in real time, right? And it is to collect, share, and share data, real life data, and to share that data to a ground system and to ensure that there is an infrastructure to make things better. So, like you mentioned, predictive maintenance, it is definitely it is definitely usable, and it is being used just to reduce fuel waste, avoid unnecessary replacements, and I would say one of the biggest users, which is definitely going to be profitable for any private entity, is to reduce ground time and maximize air time, because you're only making money when your
Flying.
inventory is in the air, right? So predictive maintenance is definitely going to help you maximize your airtime and minimize your ground time. And similarly, stuff like engine health monitoring and optimization, this is something that Parvesh, I know you have definitely worked on. And as a data engineer, you're already reviewing systems to ensure that your engine health is monitored, it is not compromised, and there are no processes or unnecessary actions taken to compromise the engine. So that is also something where IoT is definitely being used. And more than that, it is fleet level efficiency management. It is not just about managing one engine, you're managing an entire fleet. So, like you said, X amount of airplanes to X amount of engines. So, you can use IoT to track not only routes and taxi time, but you can also ensure that the energy usage is maximized. So, things like this definitely help. And finally, like you said, ground handling and airport systems reduce idle time, and they will reduce the lag or the delay because of humans in the loop when an aircraft is deplaning and replaning. So the use of IoT there is definitely sustainable, and it is showing real world usage, and it is advantages as well. So it is about now implementing this at a mass scale, not just in pilot programs, not just at big airports, but all over the place. And I feel that is the way to go about it.
Cool. Yeah, exactly. I think one of the biggest things like right now, which is coming up in like improving the efficiency of operations, is use of Gen AI with the data, which is like becoming a norm now, where if there is no aircraft system or any kind of aircraft operations which are being like used in terms of software, but it is purely basically using the data to process your airline operations, I think Gen AI is becoming a very common tool to use. So things like that are going to just keep coming in, I think. But like as an industry, I think we are still very behind the curve with using uh, the innovative techniques. And I think to improve efficiencies and sustainment, I guess that is something that aviation needs to accelerate on. There's still a lot of scope to improve on, basically. So that would be my takeaway, at least, from
Me
this.
before we leave, I think I'd already mentioned digital twin. So I feel like for any viewer who's watching us, who wants to who's thinking about what project they should try to work on, I feel like digital twin is definitely something they can work on. And I think that is the next sort of big thing, which is really going to improve operations, really going to have sustainability, and really going to help out industry in real time, because this is something that is easily achievable and integratable with current systems.
Would you like to like explain us what digital twin is?
Sure. So if you if you basically think about it, it's having a living, breathing model of your aircraft or your drone or your system in cyberspace. And engineers can test every flight, every vibration, every environmental condition that is mirrored in real time on their own system. And using sensors that are on an airplane. I'll restrict it to airplanes right now because we're talking about aviation, but using sensors on an airplane, you can test scenarios without ever touching the aircraft, and you can sort of predict what sort of reactions would happen. And now that you're getting real time data, you can actually see what is happening on an airplane without the plane having to come down. Which what happens is, once the plane comes down, after that you're doing analysis, you're wasting time. So while the plane is actively in use, you are able to at the same time mirror all of those events on your system. And such a system exists because Airbus uses its Skywise platform to create a digital twin of its airplanes. Rolls-Royce does it for its engines. And NASA also, believe it NASA was one of the first users of digital twins. I think it was used on the Apollo 13 missions. I'll have to rewatch the movie to see if it was part of the movie, but I believe digital twin was first used for the Apollo 13 missions by NASA. So it is about achieving sustainability through intelligent design and through intelligence, and yeah, that is basically the end goal of using a digital twin is to save every kg of fuel and every hour of maintenance that is avoidable, and test every design iteration before actually going on to a physical airplane. So that is a sustainable action, and that is something that definitely can be achievable and then scaled up so that the profits are available to you. So yeah, that's about it.
Yeah, I guess I think that's the biggest significant difference between Boeing and Airbus is the techniques like digital twin being used. I guess Boeing likes to, again, hot take, but I think what I've seen with most of the engineering done in the US is they, because of the tight schedules and timelines, they would rather want to physically test everything first than maybe analyze things first. So it's always been a thing where I guess that's the difference in opinions of the two cultures, I guess. So yeah, the 737 Max incident is one of those failures of doing certain digital twinning work. Maybe not a digital twin work, but actual, analysis of
Analysis.
system. Yeah, and rather than assumptions that it will be fine. So
Full of hot takes in this episode.
it's good. I think the way we are going with this series, well, this is actually episode 10. So I think the hot takes will increase every episode going forward. So it should be good.
We should have an episode only hot takes.
Maybe. Yeah. Anyways, with that being said, I guess we have I think discussed enough about sustainability. And I guess all I would like to say is anything else you wanna close off on, Ashwini, Parvesh, about
No, I'm good.
sustainability.
Uh, I
Go
mean,
research.
yeah, I mean, overall, if you feel like there is a pattern of our thoughts throughout these 10 episodes that we've done, it's that it's not just about taking a single flight or escaping into your ideas. It's about genuine progress. And genuine progress is not just about maximizing profit, it's about ensuring that everyone is safe. It's about ensuring that everything is sustainable. It's not about the profit of just one entity. It's about uh, everyone moving together hand in hand. And I feel like sustainability in aviation is one of those very important parts. And I hope through this podcast, we are able to bring that message to not only our industry, but also all of our listeners.
I think these first 10 episodes, wrapping them up, I think it's safe to say that we did put something good out there, and we're proud about it. And going forward, I think the next series we would start trying to see how we can enhance this listening experience to our viewers, and also bring up better topics to discuss. So yeah, with that being
You
said,
know
I
what
think
we
this is
can
good.
consider? We can consider like covering specific modules of the aircraft
Maybe.
or of drones.
Sure.
Can see how it's made from scratch to whatever
That could
regulation.
be that could be something, yeah.
Let us know if that is something you guys are interested in.
Absolutely. Yeah, in the comments below. But also also, yes, guests. We have many guests that we have requested to come on the show. So yeah, please do keep writing us your comments and your opinions to our platform, YouTube, Instagram, where you're listening us on. Please do leave your comments. So with that being said, that's a wrap. Thank you guys. Thank you for listening. See you in the next one.
And
Thank you
tell
for
us who's your
listening.
favorite host.
Oh, yeah, tell us who's your favorite host. I'm pretty sure it's Parvesh with his wonderful shirt that he's wearing today. So, yeah. All right. See you guys.
Bye.
Take care, guys. And just remember, through all of your highs and lows, we're all in this together.
Bye bye.
All right. See you.